Hello everyone, welcome back to my channel, The Ethical Cruise. Today I am starting a new series on the very famous topic, cloud computing. As per Gartner, cloud computing continues to be one of the most hyped and confusing terms in the history of IT. So in this video series, I will explain to you about cloud computing and then we will deep dive into some AWS concepts to uncover the cloud computing secrets. Okay, so let's start with first of all, to understand what cloud computing is, we need to understand how the website works. Okay, so I will not focus on how website actually builds, means by what language or what technology we are using. I'll try to focus more on how the website basically functions. Okay, so how website works is basically it's hosted somewhere on a server. Okay, and once we visit the website, a request get triggers from our browser to the server on whichever server our website is hosted. Okay, and as for, so what is server? So web server is just a dedicated server and it handles a request, whatever request coming from browser, and as per the request which is coming, it just responds back with the requested page. Okay, also client and server has definite IP address, and on the basis of IP address they are able to identify each other so that they can serve each other. Okay, so if you focus on this diagram, you will see uh, like this is your browser. Any browser you can take an example of, like you can take an example of Chrome, Safari, Mozilla Firefox, Internet Explorer, any browser you can take. And whenever you hit any website, let's suppose you hit that website, ethicalcruise.com. Okay, this is one of my blogging website where I write blogs all about security. You can go check this website to learn more about those. So once I'll hit ethicalcruise.com into the browser, what browser will do, browser will hit send a request to the server where this ethical cruise is hosted. Okay, how it will go, it will go over the internet. Okay, that is depicted in this diagram as network. So browser will initiate a request, that request will reach to server will see like what is that page which browser is requesting, server will process that, and then it respond back to the browser over the internet. Okay, so that's how communication between browser and server, high, this is like a high level communication. There are some more detailing about this, like how actually it behaves, but this is a very high level structure, like how browser and servers interact. Server sends a browser sends a request to server, server sees the request, processes the request, and respond back with the data to browser, and browser display the detail to you. Okay, so this is how usually website works. Okay, now if I focus more on the server part. Okay, so server is basically made up of four basic components. So the first component that we have in server is computing power. Okay, so computer is server is just like any other computer, like your desktop, your laptop, and it has some RAM as well as some CPU process whatever information which we are coming to computer. Okay, so this computer will basically, server will basically process all those whatever the request it is coming to server, and then it will respond back after the computation, all the requests with all the responses. Okay, also server has this storage. Server, as I said, server is just like any other computer, so it also has a storage, and what it does, it contains the hard drive, and it stores all the files and directories of a website. So website, if you know about website is nothing, just a directory of your files and subdirectories. Okay, and it is hosted somewhere on a server, so basically it is storing somewhere on a server computer. So that's why it servers is having a storage. Also it has a database so that it can store data in a structured manner. Okay, so whatever data we are storing on a laptop or on a computer or server, so it is some stored in a structured manner, so it server has a database which is used for this. And also server has a network. uh, it has some routers, switches, etc., to route all the data or all the requests in and out of the server. So server receives a request and server processes it, and then it sends a response back. Okay, so it do all this request transfer through network part. So these are basically four components which server requires to effectively serve any website. Okay, Now we know about how website works. Now we talked about what are the different components any server have. Now let's see what is a traditional approach to build any website. Okay, again, I'll focus more on the storage part and will focus more on how the website actually serves, not actually on how a website is usually built by using different technologies. Okay, so in general, a website is basically built using front end and back end technologies, like you know already about Java, Python, JavaScript, and all. So you know how the website is built. Okay, but when a website is built, after that, it basically needs a server to host a website. Okay, and as we already know, a server with having those four components is must to host any website. Okay, so that is a requirement after building a website. Okay, and also once we have a server, we also need a place basically to store that server. Okay, because server will be storing all the website, and we need a place basically to store the server. Okay, and if the website load is low, if our website is not that much popular, and if less number of people are visiting our website, then a smaller number of servers can serve the request, whatever request is coming to them, and henceforth henceforth a smaller number of spaces required to ho- store those servers. Okay, but if our website is huge, just like if you take an example of Amazon, Flipkart, Facebook, Instagram, so we require a large number of servers because we are getting too much of data load. We are getting too much of requests which is coming to server, and one single server will not be able to cater to all those requests. So what we will be needing a large number of servers to basically balance out the load which is coming. And to store that large number of servers, we will be needing a large amount of space. Okay, sometimes we will be needing even a warehouse to store a large amount of servers. Okay, so this is like a traditional approach when we are building any website. Okay, this used to be a only scenario when we used to build a website like a few years back. Okay, but now I'll talk you about what are the problems with this traditional IT approach. Okay, this traditional approach where we are building everything from the scratch. We are maintaining everything from on. Okay, so first of all, the very basic one is we are paying for the data centers to store the servers. Okay, so as we know, if our website is booming, if we are having large amount of data, large amount of requests which is coming to our servers, we need a large amount of servers, and to store this large amount of servers, we are basically needing a data centers. Okay, similarly, we will be maintaining the servers. Whatever server we are using, we need to maintain the server and have to pay for that server maintenance. Okay, we have to pay for that maintenance cost because whatever servers we are using, we are maintaining, it will require some cost to basically, it can be of any type of maintenance, it can be hardware maintenance, it can be software maintenance. So whatever maintenance it is taking up, we will be have to pay for that. Also, if we are using any resources, then we have to pay someone to manage and maintain those resources. Okay, like if we take an example of someone who is maintaining the server for you. Okay, like we will be hiring some IT people to basically maintain your servers so that it will be up and running. And if any request and load balancing and all, it will all be need to be maintained by those people. So it again, it is a cost which we have to incur. Also, the major drawback with this traditional IT approaches, this the limited scaling as per the demand. So let's take an example. Uh, on my website ethicalcruise.com, let's suppose as of now I'm getting 10 requests per second. Okay, and one server is able to handle that request. But let's suppose after 5 years, after next year only, I'm getting around 1,000 requests per second onto my server. Okay, but if my servers will not be able to handle it, then I will have to scale up my servers so that I will be able to cater to this 1,000 requests per second's demand. Okay, but again, if that traffic drops down again to 10 or 20 requests per second, then those servers will not be of any use to me. Okay, but I'll have to maintain those servers because again, this is not easily scalable because whenever the requests are higher, I have to increase the number of servers, and then when the requests are coming down, I have to decrease the servers because keeping the idle server will not be of any use to me. Okay, so the scaling is possible but is very limited because it will again incur some extra cost of maintaining those scaling. Okay, so these are all the problems which we used to face with traditional IT. Okay, when we used to build everything on our own. Okay, so Cloud computing basically comes with the solution of those traditional IT approach. Okay, so first, what is cloud computing? Okay, so cloud computing is an on-demand delivery of IT resources over the internet with pay-as-you-go pricing. Okay, so what cloud computing does, it delivers all the IT resources which you need whenever you need it, whatever resources you need, everything you will get it online. And what's the best part is the flexibility of whatever you are paying. Okay, so you will be paying basically for whatever thing you are using. Okay. So instead of buying, owning, and manipulate maintaining the physical data centers, the warehouses, you can access all the technology services such as cloud computing power, that is storage, the databases, everything which cloud providers provide to you. Okay, and cloud services are provided by some cloud, there are various cloud service providers, but few of them are very popular because they are the leading market leaders. Like one is your Amazon Web Service, AWS. You must have heard about it already. The second one is as Microsoft Azure, and the third one is Google Cloud Platform, GCP. So these are like the leading cloud service providers. There are also many others like Oracle Cloud, Dropbox, and all. But yeah, these are the various leading one. So these cloud providers provide you all the things, all the technologies, your servers and all over the internet whenever you need it, and you can do all the scale up, scale down. And you, by this, using this cloud computing, you can focus majorly on your website, your application building, and rather not focusing on the underlying infrastructure. Okay, so I'll talk more about like what's our benefit of cloud computing over traditional approach. Okay, the first one is scalability. Okay, so as I mentioned, since everything is being provided to us on demand, so it is easy to manage resources with on demand resource availability. Okay, whenever we want high number of resources, we can scale our resources. Whenever we want low number of resources, we can similarly scale down it. Okay, that's why as we see, like we are paying only for whatever resources we are using. So if we are scaling up, then we will pay higher, and if we will scale down again, we will pay less. So again, it is a money saver because we are paying only for resources which we are using. Okay, also in terms of servers, we whenever we are using a server, we have to maintain a backup so that if anything goes south with any one of the server, then we will have a backup that will serve us the request until that servers comes online. So in a similar way, these providers also maintain these reliability factors because they copy the data on multiple servers, and hence data loss chances are also minimal in this case because we are already having a backup. So if any servers goes down, the backup server will basically serve us with the request. Okay, and also we are not managing our servers, we are not doing the maintenance part and all. Everything is basically being taken care of by these cloud providers like Amazon, Google, Microsoft. So we are basically outsourcing our management, and we are focusing only on our building our website application and everything. Okay, so these are like the benefits of cloud computing over the traditional IT approach, due to which this cloud computing is so much in demand right now. Okay, now coming to more details, like cloud also have some deployment models. Okay, cloud service provider provides different deployment models so that to secure and manage our infrastructure. There are different deployment models of the cloud, but we will focus only on these major three of them, like the private cloud, this public cloud, and this hybrid cloud deployment models. Okay, so what the private cloud deployment model means is, so this private cloud means this is used only by a single organization, and it is not exposed to publics. Okay, so this is just like your Git repositories, public repository, private repository. So the private repository is basically not exposed to the outside world. In the same manner, this private cloud is not exposed to public. Okay, and this is basically used by single organization so that they can have a complete control of whatever they are storing on this cloud, or whatever services or whatever resources they are using. Okay, also, since this is private, they have a full security control on the sensitive application, and whatever data and everything they are storing, they have full security measures which they can have on the application as well as the data. Also, some business demands are there due to which we need to use private cloud. Okay, so these also meets those business needs. One example of private cloud providers is your Rackspace. So it provides your private cloud deployment model. Okay, second type of your deployment model is your public cloud. So public cloud is again a public, like it's like a public Git repository, which is everything is exposed to public and anyone can see and use that. So cloud resources are owned and operated by third party cloud service providers delivered over internet. Okay, and they are basically provided basically by AWS, GCP, Azure. These are like the leaders of these public cloud providers. And although the public cloud provider seems to be like this is basically exposed over the internet, but also there are various security measures which in place already to secure those public cloud so that any data is stored by any one person cannot be exposed and cannot be utilized in a malicious manner by any third party or any third person. Okay, so these the security measures are also present on this public cloud. The third one is a hybrid cloud. Okay, so hybrid cloud is just a mixture of this private and public cloud deployment model. Here some servers are kept as private on the premise and some capabilities are basically extended to cloud, like to this public cloud, to this public provider. Okay, here you will control your sensitive assets in your private infrastructure, and whatever is not sensitive, what is you can basically put it into your public cloud. Okay, some major hybrid cloud providers are like your AWS and all. Okay, so these are different deployment models. As per your requirement, you can choose whatever public, private, hybrid, whatever cloud deployment models you need. Generally, people, AWS, GCP, and Azure are the market leaders who provide you the public cloud. And we will in a series also. I'll focus more on this AWS cloud provider. Okay, so next, let's see some of the characteristics of cloud computing. So I've told you about what is cloud computing, what are the benefit of cloud computing over traditional IT and all. So what are the some of these characteristics? So there are five essential cloud computing characteristics. First one is on-demand self-service. Okay, so what is on-demand self-service? Like it does not require any human administrator. Users themselves are able to provision, monitor, and manage computing resources as needed. Meaning, we do not need any experts basically to tell us, to guide us, like you need this much or you need that much. As a user, whosoever will be using cloud service provider, like if I take the example of AWS, as a user, we will be able to provision, monitor, manage as much resources we need. And this is like an on-demand. Whenever we need to scale up, we can scale our resources requirement, and whenever we need to scale down, if any resources which we are not using, we can again scale it down. Okay, second one is large network access. These all the resources are available over the network and can be accessed by client. Okay, and can be accessed by client across the to access the cloud data, and we can also transfer the data from any place, from any device, by using an internet connection. So that's why it is large network access, because I'm taking an example of a public provider here. So we can access data from anywhere having an internet access. Third one, your rapid elasticity and scalability. This enables your cost-effective running of workload that requires a vast number of servers, but only for a short period of time. So let's suppose you are having a scenario where you need a large computation only for a short period of time. Then you will be scaling up your resources so that you can do a computation quickly. But once that is done, you will not be needing that resources anymore. So what you will do, you will just scale up for a limited number of times so that your request will be served. And once that request is done, you can just scale it back to the original number of servers so that you this is an example of your rapid elasticity and scalability. You can do it whenever as you need. So that's more like your on demand also. Okay, and also this is also one of the major characteristic of this cloud computing is your multi-tenancy and resource pooling. Okay, so what is here is multiple user groups are sharing the same infrastructure and application with security and privacy. Means there are multiple users who will be using your same application, your developers, your infra people, or your QAs. So whosoever will be using this, multiple users, they will be using the same infrastructure, but they will be a different user groups, securities, permissions will be there, which will be basically allowing the security of that application. But they are resource will be shared among all of this. So this is like one of the major characteristic of cloud computing. Okay. And the fifth one is major service. Okay. So the usage is basically measured. You are paying only for whatever you are using. Okay. So there is no such a blind or thing or something. So whatever you say you are using, you will be able to pay for that only. Okay. So if you need to scale up accordingly, your usage will be scaled up, and accordingly you have to pay for that scaled up usage. And if you are scaling down, your usage is also scaling down, and then you do not have to pay for that. Next, move on to like these are the deployment models. Next, I will tell you about like there are some different cloud computing types. Okay. There are three types of cloud computing which is generally differentiated in, like first one is your infrastructure as a service, second one is your platform as a service, and third one is your software as a service. These are various service cloud computing types which you'll have to keep in mind, because each one of this is necessary, and each type of cloud computing provide different level of control, flexibility, and management. Like an example, if I take an example of IaaS, that is infrastructure as a service. So Microsoft Azure basically provides you an IaaS cloud computing service. Also AWS provides you IaaS. There are some more like Meta Cloud, Google Compute Engine. If I take an example of platform as a service, then this Apache, this App Engine provide you this. If we take an example of SAS, so SAS more like a software as a service, which is complete software you're getting is as it is built up. Like the most efficient example is your Google app, whatever app you're using, like your Gmail, your YouTube, anything which you are using, Google app. These are just like an example of software as a service, because everything is already built upon. You're just using it. Also, Salesforce, Cisco WebEx, all are just like an example of SAS. Okay. So let's talk about this one by one. So let's talk about first infrastructure as a service. So infrastructure contains a basic building blocks for a cloud IT. So when I was telling you about how our traditional IT is built, so we have to focus on our servers, how the servers are maintained and all. So this infrastructure as a service, so this basically deals with that. So they basically provide you the infrastructure, provide you access to networking features, computers, whatever it is there, like virtual one or dedicated hardware, and also it provides a data storage to you. Okay, so all this thing you do not have to take a overhead of that, because that will be provided as a infrastructure to you. Okay, so that's why it's called infrastructure as a service. It gives you the highest level of flexibility and management control over your IT resources. So you are the one who are maintaining all those resources, but you are not running here and there to gather all these resources. Whenever you need it, you just demand it from the IS providers, and they will provide you whatever resources you need, and you can maintain it, and you can have the full flexibility and control over those resources. Okay, so these are used mainly by network architect and the developers. So whenever application you are building, so your network architect and developers, they can have full control of that. Okay, so example of which I already told you, like these are AWS EC2 instance and Rackspace, etc. These are example of infrastructure as a service providers. Okay. Next, let's talk about platform as a service. So platform as a service contains all the services which are provided by infrastructure as a service already. Also, it delivers a framework for developers that can be built upon and used to create customized application. So this platform as a service is basically is on top of that IaaS service. Okay, here some of the example here are like your Microsoft Windows Azure. So as Microsoft Azure is a example of where of a platform as a service. Also Google App Engine as well as the Heroku, where you are getting infrastructure as well as framework how you can develop your app. Everything you are getting as a platform. Okay, so that is a on top of your infrastructure as a service. And the last one is software as a service, because it includes all the services provided by platform as well as infrastructure. So SaaS provides you with a complete product that is run and managed by service provider. Okay, everything will be done by them. You just have to use it like an end user. Okay, this is like a ready-made application. Okay, and majority of software as application run directly through your web browser, which means you do not have to require any download or installation on your client side, like your machine or laptop, anything. You do not have to do anything such like that. You just have to use it directly into your browser. The example of SaaS is like your Dropbox, your Salesforce, your Gmail, everything which you are using directly into your browser, and you do not have to you do not have to do anything into this. You just have to use it. These are the premium example of like a SaaS, software as a service. Okay, so these are the different one. Also, if I take a differentiation between these, how it is for. So if you'll see in this diagram, if I take an example of on premises means the traditional IT approach where we used to manage, we used to build, we used to maintain everything on our own. So we used to build applications, used to maintain data, runtime, middleware, OS, virtualization, server, storage network, everything basically you used to maintain by yourself. When we were taking an example of, we were talking about traditional IT on premise. But when infrastructure as a service came, so what it does, it handles this networking, storage, service, virtualization, all this part of this maintaining servers and resources, it being done by the cloud service provider, and you just do this application build up basically onto your top of that services which they are providing. If we go one step ahead and go to platform as a service, platform as a service is like again a advance of that, and it even provide you the platform how you can build the application and all. It can provide you the runtime environment, your middleware, your operating system, everything is basically providing by this platform as a service. And if you take the last one is your software as a service, where everything is basically managed by service provider. You just have to use this application because the application is already ready one. Okay, if I take an analogy of all this in a journal life. Okay, let's suppose you want to prepare a meal for yourself. Okay, you have a you have all the ingredients, you have kitchen, you have a place to build, and you know how to cook. Okay, so you have everything, you won't get then it is an example of your on premise. It is because everything you are having and you are doing it on by own. So this is just an example of your on premise. And let's suppose you have all the resources to make a meal, you know how to cook, but you do not have a kitchen and gas and all. So what you will do, you can use your friend's kitchen, you can use anyone's kitchen and all, but you will be building food of your own, you will be using your ingredients. So this is an example of infrastructure as a service where you are doing everything on your own, but you are using the resources which is providing by someone else. Okay, if we take a step ahead, now you have all the ingredients which is needed to build a meal, to prepare the meal, but you do not have kitchen and gas. Also, you do not know how to cook. So what it will do, your friend will cook for you and will use his or her kitchen. So you will just be providing the ingredients to them. So this is an example of platform as a service. So in this case, you are just providing the ingredients, that is more like an application building, and everything is done by your friend. Okay, the last one is like a software as a service. You do not have anything, neither the kitchen nor the ingredients, and also you do not know how to cook. So what you will do, you will just plainly order it from online providers like Zomato, Swiggy and all. Say like an example of this Gmail and also, here you're getting a ready-made thing already built and cooked up. So these just an analogy of you can to make you understand better how what is the difference between these different cloud computing types. Okay, so this is all in this today's video. In the next few videos we will learn more about AWS in details. Okay, so this was just a starting video. Okay, where I will just talk about what cloud computing is. There is so much more to in cloud computing when I will talk to you in AWS. Okay, so just be with me, we'll talk about this in much more details. Okay, so please do like the video, share this video with your friends and colleagues so that they can also know what the cloud computing is. And do not forget to subscribe to my channel, The Ethical Cruise, Also, you can visit my blogging website ethicalcruise.com, where you can read about the security basics, footprinting, and reconnaissance and all. Okay, I'll post the link of my website in the description below. Okay, so I will see you all in the next video to continue with this cloud computing series.